So now we're going to do two more questions where we're going to solve by completing the square, but we're going to move on to actually having a coefficient on the x squared term. So we've got 2x squared plus 12x plus 17 is equal to 0. And we want to solve by completing the square to obtain exact solutions. We're going to move back and do step number 1. So remember, this was a 6-step process to begin with, but we only did 4 steps. We're going to add back in step 1 and step 4. So hopefully I can remember what these steps are because we're going to scroll to the next page. Step number 1 is if there's a coefficient on the x squared term, you can't make this a perfect square trinomial because if you think about it, we need something squared to give me 2x squared. Well, x times x would give me x squared, but what would I put to get a 2? So I have to get rid of that 2. Now, I know math sucks when sometimes you can do something one way and sometimes you can't. We are also going to be using completing the square to find the vertex. When you're talking about a function, it's not equal to 0. It won't be an equation. It'll be f of x equals. We're not going to be allowed to do things like move stuff to the other side or divide everything by something. So what I've decided in these videos is to try to do everything consistent. In other words, try to solve everything the same. So whether you're finding the vertex or you're finding an x-intercept or a solution to an equation. So what we're going to do is we are going to just factor out the 2 from the x squared and the x term. And then you're going to leave some space. You're going to have that 17 on the end, and you're going to make it equal to 0. But I will make a caveat that if you wanted to, and if you recognize that because this is an equation, you actually can, instead of greatest common factoring out the 2, you could divide both sides of the equation by 2. You'd end up with x squared plus 6x plus 17 halves, which you're allowed to put as a decimal if you want, but we're going to keep it as a fraction, equal to 0. That way you don't have to worry about this 2 out front, but I'm going to leave that up to you. So I'll follow this one through afterwards, but I'm going to follow this one through as the one that I want you to put in your notes, just because then everything you do by completing the square has the same process. So step number 1, we greatest common factored the 2 out of only these 2 terms. And the reason it's only these 2 terms is because we're trying to create a perfect square trinomial, and this is not going to be part of it. This is just kind of a tag along. And in fact, because this is an equation, you could even move that onto the other side just if it's kind of getting in the way. But what we're going to do is we're going to now make this into a perfect square trinomial. So we're going to take half that middle term and we're going to square it. So half of 6 is 3, squared is 9. What we do to what if we're going to add, we also have to subtract so that we can keep our equation the same. Then that's steps 1, 2, and 3. Step 4 is a step we haven't had to do yet. It's called pay the toll, which is that you don't want the -9. The -9 is not part of the perfect square trinomial. So you're going to take it out of the bracket by multiplying it by the 2. So the thing that's keeping it in the bracket is this multiplying by 2. So you can pay the toll and get it out. Right? In other words, you'll have 2 times x squared plus 6x plus 9, and then you're going to have 2 times -9 on the outside with that plus 17. You end up with 2 times, now this is going to factor to x plus 3 all squared, and then we have minus 18 plus 17 is minus 1 is equal to 0. And that's it. That's all that was new. So the 2 new steps were that if there's a coefficient on the x squared term, factor it out of just the x and the x squared, because the constant just comes along for the ride. And then once you've created that perfect square trinomial, take the negative constant out of the bracket by multiplying it by the number out front. Now we're going to keep solving this one algebraically. So I'm going to add 1 to both sides. Then I'm going to divide by 2 to both sides. Then I'm going to take the square root. Now for this one, you can notice that you have an irrational denominator. So I'm going to multiply by root 2 over root 2 to rationalize the denominator. I end up with x equals -3 plus or minus the square root of 2 over 2. And that can be your final answer. Or you could make this into a denominator of 2 by multiplying by 2 over 2 and get negative 6 plus or minus the square root of 2 all over 2. So these ones always get that sort of like fractional answer, and there's often this irrational denominator that you have to rationalize. But really, the process is only 2 steps bigger. Greatest common factor, oops, I don't know why it's doing that today. Greatest common factor, and then pay the total to get the negative constant out of the bracket. If you had done it by dividing everything by 2 first, the process is going to look very similar. So you're going to have x squared plus 6x plus 9 minus 9. Then these are the ones that are going to go to the other side. You can combine them. This is my perfect square trinomial. So I'm going to have x plus 3 all squared. Now negative 9 plus 17 over 2. 9 over 1 would be negative 18 over 2. So I've got negative 1 over 2. And then I end up with x plus 3 all squared is equal to a half. So even if I do that, I kind of end up just at the same place. It's just a different way of getting there. So it really is fine. If you notice that because it's an equation, you can divide everything by 2 and you find that easier to not have to do the pay the toll thing and not to have to remember who to factor the 2 out of, go for it. But I will say, when we solve by completing the square to find the vertex, you're going to have to do this. So you might as well practice it doing it this way now anyway, so that it doesn't feel different. But some people are okay with different rules for different things. All right, here's another one. So again, we have a coefficient on the x squared term. I have two choices. I can divide everything by negative 3, or I can just factor that negative 3 out of these two terms. I would end up with x squared minus 4x, leave a bunch of space, is equal to 2. Then I'm going to create that perfect square trinomial. So I'm going to take half that middle term and I'm going to square it. So negative 2 squared is 4. I'm going to add 4. I'm going to subtract 4. Then I'm going to make sure that I don't need that negative constant. So I'm going to take it out of the bracket by multiplying it by negative 3. I end up with negative 3 times x squared minus 4x plus 4. And then I've got this negative 3 times negative 4 on the outside is equal to 2. And then keep going. We've got negative 3 times x minus 2 all squared. And then I've got plus 12. I've got negative 3 times x minus 2 all squared is equal to negative 10. Then I'm going to divide both sides by negative 3. That gives me x minus 2 all squared is equal to positive 10 thirds, because a negative divided by a negative is a positive. Then I'm going to take that square root. I'm going to rationalize that denominator. And I end up with x is equal to 2 plus or minus the square root of 30 over 3, or if I create that common denominator of 3, that's going to be 6 plus or minus the square root of 30 all over 3. And yes, you're always checking to see if you can simplify this radical, but we can't. There is no perfect square that divides evenly into 30. And no, you cannot do 6 divided by 3 without also doing the 30 divided by 3, right? The root 30 divided by 3. So this would be my final answer, or this would be my final answer. You get to choose. Awesome. There are some questions. There's a question in your homework that says challenge. It's one that, if I chose a question that looked like this, right? So if I factor that 2 out, I end up with x squared plus 3x. And it's like, do you want to? Do you want to try the challenge? Do you want to then complete the square with one that's odd? Or do you want to just wait until we learn how to use the quadratic formula for those? So the challenge one is totally up to you. I won't put it on a test. But if you're up for a challenge or looking for a challenge in this course, feel free to do that one by completing the square as well. All right, good luck.